Hello, fabulous fourth grade. Today we're going to talk about the sun and the earth. We're on lesson 1, day 1. The standard for this lesson, 4.ESS 1.2. Use a model to explain how the orbit of the earth and the sun cause observable patterns. A, in day and night, and B, changes in length and direction of shadows of day. So let's look at our know and show for this particular standard. What is it that we need to know in order to complete this standard? We need to know, we need to know about the earth. We need to know sun. We need to understand patterns. We need to know about day and night. We need to understand length, direction, and shadows. What is it that we need to show? Remember, show is our verb. It's an action word. What is it that we need to show for this particular standard? We need to be able to model. We need to be able to explain. We need to be able to look at changes. We need to understand direction. So these are things that we need to be able to know and show at the end of this lesson. Let's talk about our guiding question for this lesson. At the end of this lesson, we should be able to explain what causes the day and night cycle on Earth. So as we go through this lesson, you need to think about and keep in mind what causes the day and night cycle on Earth. Your learning outcome for this lesson. I will be able to demonstrate how the rotation of Earth causes the day and night cycle. Read that aloud to yourself. Now, at the end of the lesson, this is what you should be able to do. You should be able to demonstrate or show how the rotation of Earth causes the day and night cycle. And as we go through this lesson, boys and girls, we're going to learn what the word rotation means. You're going to learn about rotation and understand how the Earth rotates. Let's take a look at our first vocabulary word for this lesson. Axis. An axis is an imaginary line drawn through the north and south poles. If you look at the picture, you will see the axis that is drawn through the north and south poles on the earth. It is also labeled as axis on the picture. So remember, an axis is an imaginary line drawn through the north and the south poles. The next vocabulary word is revolution. The Earth completely passes around the sun, taking 365 and 1/4 days or 1 year. So when the Earth does a revolution, if you look at the picture, it is going around the sun. The sun does not move. It is the Earth that is moving, and the Earth revolves around the sun. If you notice in the definition, it says it takes 365 and 1/4 days, or 1 year. Do you know why the year is counted as 365 and 1/4 days? Think about it for a moment. Why is the year calculated as 365 and 1/4 days? So it is calculated this way because every 4 years we have a leap year. So in 2020 this year, We had 29 days in February. That will not happen again for another 4 years. That's why it is calculated as 365 and 1/4 days, or 1 year. Your next vocabulary word is rotation. A rotation is a complete spin on the axis. So if you look at the picture once again, it is showing you an example of what Earth's rotation looks like. The Earth rotates on its own axis. So you see the picture of the axis that is going through the North and the South Pole, and it's showing you the direction that the Earth rotates on that axis. So the rotation is the complete spin on the axis. Let's take a look at this anchor chart. Rotation versus revolution. When the Earth rotates, it spins or it turns, and a rotation takes 24 hours, which makes 1 day. This rotation causes day and night. When the Earth revolves, that means it goes around, and it takes 365 days or 1 year. This causes our seasons: spring, fall, winter, and summer. So the difference between rotation and revolution: when the Earth rotates, it gives us day and night, and when it revolves, it gives us our seasons. Please take note of this anchor chart. You may want to add it to your notes. This is some very important information because you will always need to know the difference between rotation and revolution when it comes to the Earth. Here's a little something for you to think about. Every day the sun rises and sets. At dawn, or in the morning, it appears in the east. You'll find it in the west by sunset. Is the sun really moving across the sky? Or is the Earth moving? Think about that for a moment. Is the sun really moving across the sky, or is the Earth moving? Take a few minutes to think about that question. Earth rotates. So every day the Earth completes one rotation. It takes 24 hours to complete that one rotation. Hours are divided into minutes, and minutes are divided into seconds. So we have 60 minutes in 1 hour, and we have 60 seconds in 1 minute. But every single day, the Earth completes one rotation every day. As the Earth rotates, you can see different parts of space. So if you go outside and look up in the sky in the daytime and at night, you will be seeing different parts of space as the Earth is rotating. During the day, the side of Earth where you live faces the sun. So during the daytime, where we live is facing the sun, and the other side of the Earth is having nighttime. As that part turns away from the sun, it becomes night. So the Earth is moving, it is rotating, and we're experiencing day. The other side of the world is experiencing night. The Earth rotates, and when we are experiencing night, the other side of the world is experiencing daytime. The rotation of the Earth changes day into night and night into day. So rotation is what causes day and night. Apparent motion is the way something appears or seems to move. So you may say, apparently, it seems like the earth is moving. So apparent motion is the way something appears or how it seems to move. The sun appears to rise in the east and it seems to set in the west. So we have a saying that it rises in the east and it sets in the west. And usually if you're driving or riding around with your parents in the car late in the evening, you can see if you're driving west, you know you're driving west because the sun is very blinding. And so either your parents have on some shades or sunglasses or they pull down the sun visor to block the sun. In the morning time, you'll know if you're going in the east because that is the direction that we say the sun arises or it appears. And that's where the sun is the brightest. And that is another time where you're trying to shield or protect your eyes from the sun. So the sun appears to rise in the east and it seems to set in the west. Apparent motion, though, is not real motion. It is an appearance that something is moving. Earth's rotation causes the apparent motion of many objects in space. It seems that stars move across the sky. The moon and planets do not always move in the same direction as their apparent motion. So Earth's rotation makes it seem that objects in space are moving. Now let's talk a little bit about shadows. I know you all have dealt with shadows. You'll be sitting and there's a light reflecting and you'll try to make shadow puppets on the wall. So I know you all have played around with shadows. Or when you were younger, or you've seen a younger child, if you have a younger sibling, they walk around outside and they will try to walk on their shadow or step on their shadow. So we're going to talk a little bit about shadows. A shadow forms when light is blocked. The light strikes an object but cannot pass through it. When your body blocks the sun, you can see a shadow. And a shadow always points away from the sun. So if you notice, you ever go outside and look at your shadow or look at an object that is casting a shadow, you'll notice that the shadow is actually pointing away from the sun. But a shadow happens when light is blocked. So anytime you're trying to block the light, you're going to show, it's going to show a shadow. As the position of the sun changes, so does your shadow. So early in the morning, your shadow is very long. It's pretty long. Then in the middle of the day, it shrinks. Around sunset, your shadow grows longer again. So in the morning it's longer, then it shrinks until about midday, and then as it gets later in the evening or closer to sunset, your shadow grows longer again. That's an experiment you can try. Go outside early in the morning and look at your shadow. Then go out there again about midday and check your shadow again. And then go one more time when it's closer to sunset and look at your shadow. You should be able to see the difference. Let's take a moment to do a quick check. How might you use the sun to estimate the time of day? Think about it for a moment. How might you use the sun to estimate the time of day? Let's take a look at this anchor chart that talks about what causes day and night. In this particular anchor chart, you can see the picture of the earth and it shows the axis. It shows one side of the earth pointing away from the sun and it shows the other side of the earth that is pointing towards the sun. It identifies as day and night. It also shows what causes seasons. So at the bottom, you'll see the sun and then you will see the earth as it revolves around the sun. This gives us our seasons. Take a look at this anchor chart. It gives quite a bit of information on what causes day and night. It is just a different representation of an anchor chart that shows day and night. Let's take a moment to do a quick check. What causes Earth's cycle of day and night? What causes the Earth's cycle of day and night? Think about that for a moment. Now we're going to take a look at what causes seasons. We know that Earth revolves around the sun. And we know that the word revolve means to move around another object. A revolution is when one object makes one complete trip around another. So let's look at what causes seasons. And we know what our seasons are. What are our seasons? The path a revolving object takes is its orbit. Earth's orbit is shaped like an ellipse or a flattened circle. So it's not going in a complete circle, a perfect circle. It's kind of like a flattened circle, and that's the orbit that the Earth makes. Earth's revolution around the sun takes 365 and 1/4 days, or 1 year. And earlier we talked about that 365 and 1/4. Think about for a moment how 365 and 1/4 days is equivalent to 1 year. Think about that for a moment to make sure you remember. So we know that Earth's axis is tilted. The tilt always points in the same direction, so the tilt never changes. The tilt causes sunlight to strike Earth at different angles. And at any given time, each hemisphere or half of the Earth gets more or less sunlight. So depending on the tilt, the hemisphere or the half of the Earth gets more or less sunlight. We know we're broken up into hemispheres, and that is the Earth is like in parts. We live on the northern hemisphere, so the United States is on the northern hemisphere. The seasons result from both Earth's tilted axis and the orbit around the sun. So the seasons are dependent upon two things: the Earth's tilted axis and its orbit around the sun. So the seasons differ from place to place. So different places have different seasons. When it is winter here in Tennessee, it is summer in South America. So right now we're in spring in Tennessee, which means, what do you think the season is in South America right now? Think about that. It is spring here in Tennessee. What is the season right now in South America? Now that you know what the season is in South America, how do you think it is possible? How is it possible for it to be winter in Tennessee and summer in South America, or right now it is spring in Tennessee and autumn or fall in South America? How is this possible? Think about that for a moment. So, as I just told you, the United States is located in the northern hemisphere. In July, the North Pole tilts toward the sun. So in July, the North Pole will be tilting toward the sun. Sunlight hits the northern hemisphere at steep angles. The light is more intense, so it is summer. The reason why it is so hot in July is because the North Pole is tilted more towards the sun at that time. And because we are in the northern hemisphere, it makes it a whole lot warmer here in the summer. In January, the North Pole tilts away from the sun. Sunlight strikes the northern hemisphere at a low angle. Now it is winter. It's a whole lot colder. However, the southern hemisphere is tilted towards the sun in January, so therefore it is summer in January. So while the northern hemisphere is tilted away from the sun, the southern hemisphere is tilted towards the sun, and that gives them summer and gives us winter. It's time to do a quick check. What causes the seasons? According to what we've just gone over, what causes the seasons? Here's another quick check. What would happen to the seasons if Earth's axis were not tilted? What would happen to the seasons if Earth's axis were not tilted? Think about that for a moment. Near the equator, the sun's apparent path changes much less during the year. So the closer it is to the equator, the sun's apparent path doesn't change as much during the year. Temperatures there change little from season to season. So usually near the equator, the temperatures kind of remain steady. They kind of remain stable and are the same. All year, sunlight strikes at similar angles. So at the equator, they usually have the nice tropical weather because the sun is striking at the same position throughout the entire year. Near the poles, the sun's apparent path is very different between seasons. So the closer to the north and the south poles that you get, the sun's apparent path is different. In northern Alaska, for instance, summer nights are very short. And remember, boys and girls, we talked about the day and the night cycle in Alaska. So this explains why in Alaska the days and nights are so long. So in northern Alaska, for instance, summer nights are very short. During the winter, the sun hardly ever appears. So we talked about how they experience darkness for 6 months and then daylight for 6 months. Well, this would explain why. Summer nights are very short because the closer that near the poles, the sun apparent path is very different in seasons. So when we talk about Alaska, it's closer to the poles. So the seasons are very different. They don't have seasons like we do. It's a little bit different in Alaska than it is here in the United States. So if you've ever wondered how scientists can predict when the sun will rise and set, because if you've ever watched the weather, they will give you a time that the sun will rise, and then they'll give you a time for the sunset. Well, I know you're wondering, how can they figure that out? The sun's apparent path changes in the same pattern every year. So the sun's apparent path changes at the same time in the same pattern every year. Scientists take these patterns and they make predictions. So they're predicting the time that the sun will rise and the sun will set. They're making predictions. And we've talked about how we make predictions and how scientists make predictions. So they're making predictions to tell when they think the exact time that the sun will rise and the exact time that the sun will set. Let's do another quick check. How does the sun's apparent path change over the year? How does the sun's apparent path change over the year? Why are the differences so large near the poles? Why are the differences so large between the North Pole and the South Poles? So, in closing, let's review. Earth revolves around the sun. Earth's revolution around the sun takes 365 and 1/4 days, or 1 year, and this is what gives us our seasons. Every day the Earth completes one rotation. One rotation takes 24 hours. The rotation of Earth changes day into night and night into day. You may want to stop and jot these quick notes down for your future reference. Let's go back to our guiding question. What causes the day and night cycle on Earth? What causes the day and night cycle on Earth? Now that we've gone through the lesson, can you answer this question? All of your assignments, boys and girls, have been uploaded into your McGraw-Hill, into your science link. So if you log into Clever, like you normally would to do your iReady, then you scroll down to find the red and white app that says McGraw-Hill. Click on the McGraw-Hill app. Once you go in, you will see where it says Science Student Textbook. Click on that link. When you get into it, you will see all of your assignments listed on the right-hand column. Don't concern yourself with the due dates. I had to fix it so that the due dates will come up so that you all will be able to see all of your assignments. All assignments you do have for the month of April to work through them. They are exactly the replica of your workbook, as well as all the information that you would see in your textbook and in any of the PowerPoints I would present in class. So if you work through that information, it should come pretty easy to you because it's the exact same thing we do in class each week when we do our science lessons. Once you complete your lessons, your parents may email them to me, or they can send them directly to me through Class Dojo through the messenger. Do not send them through the announcement part. Send them directly to me through the messenger part of Class Dojo if you choose to use Class Dojo, or they can email it to me through my work email, which is cheersam@scsk12.org. I will give it to you again at the end. So once you've completed your assignments, your parents can feel free to email them to me or to send them to me directly through Class Dojo. If at any time you have any questions, you're confused, or cannot log into McGraw-Hill into your textbook, please have your parents message me on Class Dojo, and I will do all I can to help them work through the process. So my email address is listed here, cheersam@scsK12.org. Copy this email address down, and if at any time you would like to submit an assignment or your parents need to reach out to me, they can feel free to reach me through my email or through Class Dojo.